unit step function. F of t equal to 0, 0 less than t, less than a, equal to 1, a, t, greater than a. Let us draw a graph. A up to distance a, here f of t, this is t axis, one distance up. This is a simple diagram. F of t can be denoted as f of t or u of a t or u of t minus a. These are the symbols. These two are the symbols mainly being used in unit step function. We can write this like this: instead of f of t, u of a t. U of a t equal to 0, 0 less than t, less than a, equal to 1 t greater than a. Let us write Laplace transform of uat equal to 0 to a e power minus st uat dt plus a to infinity e power minus st uat dt. We can write f of t also here. 0 to infinity uat is 0 to the limit 0 to a, completely 0. A to infinity e power minus st uat is 1 when t greater than infinity, t greater than a, therefore 1 dt. Integrating 0 a to infinity e power minus st dt. E power minus st by minus s integrated a to infinity. E power ax dx basic integration equal to e power ax cos of x is a dividing a. Similarly, we have integrated. Give the upper limit e power minus infinity. We have integrated with respect to t, giving the upper limit infinity, t is infinity minus infinity, which is minus s minus e power 0, giving e power a, e power minus as, giving t is lower limit a minus s. E power minus infinity is 0. Therefore, this is completely 0. Minus e power 0 is e power minus as by minus s. Therefore, e power minus as by s is the Laplace transform of unit step function. We can simply write f of t equal to 0 when 0 less than t, less than a, equal to 1 t greater than a. If 0 comes, we should not touch that. If 1 comes without 0, whatever the function of t may be, if 0 comes, we should not touch this 1. Therefore, L of f of t or L of u of a t. Here is a, suffix a. Therefore, we have to take e power minus as for all sums, whatever the suffix in comes, should be exponential negative power of s into L of 1. Therefore, e power minus as by L of 1 is s is the simply we have done. See, L of u of at equal to e power minus as by s. We have just seen. If L of u of 0t means L of 1 u of 0t equal to 1. L of 1 is 1 by s. Similarly, a is 0. If a is 0, if you put 0, it will come e power 0 1, then 1 by s. Simply L of 1 is 1 by s we are getting. This is unit step function. Again we are going to see shifting property. This is called second shifting property or second shifting theorem. If second shifting theorem property, second shifting property, if L of f of t minus a u of a t equal to e power minus as if L of f of t is phi of s, then Laplace transform of f of t minus a f of t minus a u of a t is e power minus s by function of s, where a is any constant, any positive constant uat is a unit step function. U is an unit step function. Let us give proof for this. L of f of t minus a u of a t 0 to infinity e power minus s t f of t minus a u of a t dt. Split into 2. 0 to a e power minus s t f of t minus a u of a t dt plus a to infinity e power minus s t f of t minus a u of a t dt. By unit step function u of a t equal to 0 when 0 less than t less than a equal to 1 t greater than a. We are applying here. Up to 0 to a u of a t is 0. 0, completely 0. And a to infinity e power minus s t f of t minus a u of a t is 1. For this limits u of a t is 1. a to infinity, t greater than a means t greater than a of 1 dt. A to infinity e power minus st f of t minus a dt. By substituting t minus a equal to u. T and u are variable. A is a constant, positive constant. Therefore, dt equal to du. T equal to a plus u. When this is integral with respect to t only. When t equal to a, u is a minus a, 0. When t equal to infinity minus something same infinity, u also infinity. Applying this limit for this and changing into u equal to 0 to infinity e power minus s, t is a plus u f of t, dt is f of u du equal to 0 to infinity e power minus as e power minus au su f of u du. E power minus as taken out, 0 to infinity e power minus su f of u du. We are changing dummy variable here. Instead of u, we are writing t. Let us write here e power minus as 0 to infinity e power minus st f of t dt. Instead of u, we have changed t here as dummy changing the dummy variable. Therefore, e power minus s for this Laplace transform of f of t, which is function of s, is the answer, is the proof. We can write shortly L of f of t minus a u of a t equal to e power minus as L of f of t. This is a short way we are going to write in all sums. E power minus as L of f of t is function of s, phi of s. This is in short way we are going to use in many examples, many sums. Let us do the sums one by one. First sum. Find the Laplace transform of f of t equal to 0, t greater than 2 equal to t minus 3 whole square, 0 less than t less than 2. We are going to write in unit step function application. L of, if there is function 0, you don't touch that for any sum. You only see function is there, you only see this. See, t minus 3 whole square, 0 means u0t. Right outside. First let us the function f of t equal to, let us write the function f of t equal to t minus 3 whole square in bracket. This is 0 means u0t, and at this side u of 2 0 u20t u2t. This way of writing for all sums. If there is a 0, don't write in any sum. If you use unit step function, if there is a function, write this, and first 0 u of 0t to u2t. This is a way of writing in unit step function. Writing the function in unit step function. Let us do Laplace transform of f of t. F of t equal to L of t minus 3 square, let us bracket, full bracket, of u of 0t minus u of 2 of t equal to Laplace transform of t minus 3 whole square of u of 0t minus Laplace transform of t minus 3 whole square u of 2t. L of t minus 3 whole square u of 0t is 1. Therefore 1. Close the bracket. L of, we have to change t minus 3 into t. Then e power minus 2s come out. We have to, yes. Let us make t minus 2 inside. T minus 2 minus 1 whole square u2 of t. L of t minus 3 whole square minus L of, here is 2 here, therefore here 2, we have created 2 minus 2, therefore e power 2t, 2s, e power minus 2 is taken out. As per unit step function, e power minus 2 is taken out. L of t changed into t minus changed into t minus 2 into t to t. We are changing t minus 2 to t. Therefore, t minus 1 whole square here u of 2t is, u of 2t, we are writing e power minus 2s outside. If you take Laplace transform, this is the finally this is the answer. L of t square minus 60 plus 9 minus e power minus 2s, L of t square minus 2s plus 1. L of t squared is 2 factorial divided by s cubed. L of t means 1 factorial divided by s square. L of 9, L of 1 is 1 by s minus e power minus 2s. L of t squared is 2 factorial divided by s cubed minus 2, s means 1 factorial divided by s square plus 1 by s is the answer. We can write the sum in direct way without entering into unit step function. The same answer you will get if you do the indirect way. See, write the answer to factorial by s cubed minus 6 by s square plus 9 by s e power minus 2s by 2 by s square minus 2 by s cubed s square plus 1 by s. Same result we will get if we do the sum by direct method. Let us do direct method. F of t equal to 0 when t greater than 2 equal to t minus 3 whole square when 2 less than 0 less than t less than 2. Let us do direct method. L of f of t equal to 0 to infinity e power minus st f of t dt. 0 to 2, splitting into 2, 0 to 2 e power minus st f of t dt plus 2 to infinity e power minus st f of t dt equal to 0 to 2, 0 to f of t is e power minus st f of t is t minus 3 whole square dt plus which is 0, 2 greater than infinity is 0. Let us integrate this. 0 to 2 e power minus st t minus 3 whole square dt. By a normal integration, you are doing this sum, you will get the same answer. 0 to 2 t minus 3 whole square e power minus st dt by Bernoulli's integral uv minus u dash v1 plus u double dash v2. This is called Bernoulli's integral. U is directly taking t minus 3 whole square. U dash is differentiation. T minus 3, 2 comes of chain rule with respect to t is 1. U double dash again differentiating 2 only 2t, differentiating 2t is 2. V is, we are not directly, as differentiation we are taking directly e power minus t. V is taking integrating e power minus st as a v. E power minus st by minus s again. V1 is again integrating e power minus st by minus s which is e power minus st by s square. Again integrating V2 e power minus st by s square minus s e power minus st by minus s cubed. These are all writing for this formula. This is called Bernoulli's integral. Time is positive, u is positive, v is negative at this side, minus t minus 3 whole square into e power minus st by s. Time is negative, u dash is positive, v1 is positive. Therefore, minus 2 into t minus 3 e power minus st by s square. Take the third. U double dash is 2. Time is positive. U double dash is 2. And V2 is negative. Here negative, here positive, negative. Therefore, negative comes 2 into e power minus st by s cubed. Limit is 0 to 2 integrated. Applying upper and lower limit, we are going to see the same answer. Your upper limit, t is 2. 2 minus 3 is minus 1. Already minus 1 is there. Plus 1. The plus 1. It comes. T is 2. 2 minus 3 is minus 1. Whole square is plus 1. Here is minus, already minus. T is 2. 2 minus 3 minus 1. Whole square is plus 1. Already minus is there. E power minus is yes, 2s. 2s by s. Giving, we have integrated with respect to t, applying wherever t comes, 2 we are giving upper limit. Minus, here give you 2, 2 minus 3 is minus 1, already 2 is there, minus is there, plus 1, 2 into e power minus 2s by s square. Again, minus 2 e power minus 2s by s cubed. See this, that sub comes here. S cubed minus 2, the same comes here in the bracket. Again, lower limit 0. If we give 0, minus 3 also is 9, and minus is there. Minus 9, e power 0 is 1 by s, and by s comes. Again, if you put 0, minus 3 is there, plus 6. Plus 6 by e power 0 is 1 by s square. We can write 1 by 1 also. E power 0 is e power 0. E power 0. 2 gives minus 1 plus 2 gives minus 1. 0 gives minus 3 minus 6. 0 gives minus 3 plus 6. Plus 6. Plus e power 0 is 1 by s square. If you give 0, minus 2 e power 0 by s cubed. We can see this answer as in the unit of what we have done already in the unit step function. Shortly writing e power minus 2s minus 1 by s 2 by s square minus 2 by s cubed is the answer. Comes, the sign changes, comes. Again, minus and let us remove the bracket. Plus 9 by s minus 6 by s square plus 2 by s cubed. 2 factorial s cubed minus 6 by s square, 2 by s cubed is the answer. We have done this sum by direct method, by direct Laplace transform. Previous method is by using unit step function. In unit step function, we are getting answer very quickly. Let us do sum number 2. If f of sum number 2 if f of t equal to t 0 less than t less than 5 equal to 7 t greater than 5, we are going to see in both the methods. First method is by unit step function. Method 2 is by the direct method. Method 1. Method 1. Let us do unit step function. Function of t equal to t into t. Here is not 0, therefore we can write 2. Here 0 and 5 is there. 0 and 5 are there. Therefore, u of 0t minus u of 5t. For this first limit, we have written like this. Plus, here is 7. 7 into u of phi t. This is the way of writing to use unit step function. T, u of 0 t is already we know 1. Initially we have seen in the first proof 1 minus u of phi of t plus 7 u of phi of t equal to t taking Laplace transform on both sides, L of f of t equal to L of t 1 minus, let's write a flower bracket, t into 1 minus u phi t plus 7 of u phi t equal to L of t minus t of u phi t plus 7 of u phi t equal to L of t minus bracket t u phi t minus phi plus phi u phi t plus 2 u phi t. We have split 7 into 5 plus 2 u phi t. Again L of t minus, taking the bracket for these two, minus of t minus phi of u of phi t plus 2 of u of phi t. Taking L inside this, L of t minus L of t minus phi u of phi t plus 2 L of u of phi t. L of t is L of t here e power minus phi s. We have used the here phi is there, here of t minus phi. L of t minus a u of a t equal to e power minus a s L of t minus L of t. L of t we have written already, but this is the way of using unit step function. L of t minus a changed into t. Similarly, t minus phi changed into t, L of t. UAT is not there. Plus 2 e power minus phi s L of 1. There is no function, therefore 1. L of t is 1 factorial divided by s square. First formula, we are the eighth formula from the standard forms. Minus e power minus phi s L of t is 1 factorial by s square plus 2 e power minus phi s L of 1 is 1 by s. 1 by s square minus e power minus phi s by s square plus 2 e power minus phi s by s. This is the answer. The same sum we are going to see in direct method. S square minus e power minus phi s by s square plus 2 e power minus phi s by s. Let us do the sum by direct method. Find the Laplace transform of method 2. Method 2, direct method. L of f of t equal to t when 0 less than t less than 5 equal to 7 t greater than 5. L of f of t equal to 0 to infinity is the Laplace transform of basic line e power minus st f of t dt. We are going to split into two. 0 to 5 e power minus st f of t dt plus 5 to infinity e power minus st plus e power minus st f of t dt. 0 to 5 e power minus st f of t is t dt plus 5 to infinity e power minus st f of t is 7 dt. 0 to infinity t e power minus st dt plus 7 taken out 5 0 to 5 5 to infinity e power minus st dt. This is Bernoulli's integral. We are going to see Bernoulli's integral, first integral. That is t e power minus st dt. Here uv minus u dash v1. U equal to t. U dash equal to 1. V equal to e power minus st by minus s. V1 equal to e power minus one more minus s e power minus st by s square equal to u is t, v is u is time is positive, u positive, v negative, therefore minus t e power minus st by s. Next, time is negative, u dash is positive, v1 is positive, therefore minus e power minus st by s square integrated. We are writing into this minus t e power minus st by s e power minus st by s square. Limit is 0 to 5 plus 7 into, we are integrating e power minus st by minus s. Integration limit is 5 to infinity. Using the upper lower limit for the both integrals, upper limit is 5 minus 5 e power minus 5s by s e power minus 5s by s square, upper limit, minus lower limit 0, 0 complete is 0, t is 0, e power 0 is 1, e power 0 by s square, upper lower limit for the limit we have written. Similarly, upper limit for infinity, e power minus infinity by minus s, common negative, limit is 5, e power minus 5s by minus s. Directly minus s written in this side, directly written the upper lower limit inside the bracket, minus s kept below, and removing the bracket, minus 5 e power minus 5s by s for minus 5s minus e power minus 5s by s square plus 1 by s square. This minus comes at the front, minus 7 e power minus infinity 0, 0 e power minus 5s minus plus e power minus 5s by s, and again removing the bracket, minus 5 e power minus 5s by s minus e power minus 5s by s square plus 1 by s plus 7 e power minus 5s by s. See, 1 by s is there. 1 by s square. 1 by s square is there. E power minus 5s 7 times, here 5 times. Subtracting 2 times of this. And I am writing here 1 by s square minus e power minus 5s by s square. Where's s square? 7 minus 5 plus 2 times of e power minus 5s by s is the answer. In both methods, we are getting the same answer. Again, sum number 3. Method 1. Method 1 is using unit step function. If f of t equal to 0, where 0 less than t less than pi by 2 omega equal to sin omega t pi by 2 omega less than t less than pi by omega equal to 0 when t greater than pi by omega. We are going to this first method is unit step function method. Or second shifting property. Here 0 comes function. Don't touch that. Here also 0 comes. Then also don't touch that. Without 0 here. See, f of t equal to, we are writing function sin omega t into u of pi by 2 omega t suffix, we are writing suffix minus. First term is front, writing at the front. Second is u of pi by omega t. This is of writing the application in unit step function. See, let us take it into side. Sin omega t u of pi by 2 omega t minus sin omega t u of pi by omega t. Taking Laplace transform on both sides. L of f of t equal to L of sin omega t u of pi by 2 omega t minus L of sin omega t u of pi by omega t. We have to create t minus a, which should be changed into t. Here a is pi by 2 omega. Therefore, L of sin omega of into pi by t minus pi by 2 omega plus pi by 2 omega. We have created of u of pi by 2 omega t. Similarly, minus L of sin omega t minus pi by omega, adding and subtracting pi by omega u of pi omega of t. applying the unit step function rule, which is this is called A is pi by 2 omega, which is changed into T L of sine e power comes out e power minus pi by 2 omega is L of sine omega into T minus pi by pi omega change into T minus pi by 2 omega into T change into T plus pi by 2 omega. It is not there, it goes out, minus e power minus pi by omega is L of sine omega T minus omega pi by omega changed into T. Therefore, T plus pi by omega. Unit step function steps applied. E power minus s pi by 2 omega L of sine omega t plus omega cancel pi by 2 bracket close minus e power minus pi by omega is L of sine omega t plus pi only. E power minus s pi by 2 omega, we know sine pi by 2 plus theta equal to sine 90 plus theta, which comes in second quadrant. We are going to use all silver teacups. If pi by 2 comes cos theta, if it comes in the second quadrant, all silver, sine is positive. Therefore, if pi by 2 comes cos, therefore it is positive. Therefore, cos omega t, L of cos omega t, we have changed. Minus e power minus pi by omega is L of, here sine pi plus theta, pi is 180, which is third quadrant. All silver teacups, tan and cot only positive. Remaining trigonometric functions are negative. Trigonometric ratios are negative. Therefore, 180 plus theta is minus, if pi comes same, sin theta. Pi by 2 comes cos theta, co-ratio changes, and if pi comes same, sin theta, which is in third quadrant, 180 plus theta, which is also t, therefore minus sin theta here, minus sin omega t, minus sin omega t. Equal to e power minus s pi by 2 omega s by s square plus omega square. Basic 8 formula used here. L of cos at equal to s by s square plus a square, we have used here, minus e power minus plus comes e power pi s pi by omega s L of sin omega t, L of sin at we already know what a by s square plus s square. Therefore, e power minus s pi by 2 omega s by s square plus omega square plus e power minus s pi s pi by 2 omega, any form we can write, e power pi by omega s minus pi by omega s omega by s square plus omega square is the answer. We are going to see the same sum by method 2, direct method. Let us write the answer to verify. Pi s by 2 omega s by s square plus omega square plus e power minus pi s by omega by s square plus omega square. To verify, we are writing an answer at this side. Method 2. Sum number 3. Direct method. If f of t equal to 0, where 0 less than t less than pi by 2 omega equal to sin omega t pi by 2 omega less than t less than pi by omega equal to 0, t greater than pi by omega. Laplace transform of f of t equal to 0 to infinity e power minus st f of t dt. We are splitting into 2. 3 parts, split into 3, 0 to pi by 2 omega e power minus st f of t dt plus pi by 2 omega to pi by omega e power minus st f of t dt plus pi by omega to infinity e power minus st f of t dt. This first integral and last integral 0. First and last 0. Center only we are getting for instead of for f of t sin omega t. Equal to 0 plus pi by 2 omega pi by omega e power minus st sin omega t dt plus 0. Last is 0. Integrating. We are going to use this formula e power ax sin bx dx equal to, let us write it from the front, e power integration of e power ax sin bx dx equal to e power ax into a sin bx minus b cos bx divided by a square plus b square. See, if sin comes, it will start from sin. Negative is there. If cos comes, it will start from cos. There will be positive. This is the method of keeping in mind these types of exponential with sin cos. We are applying this. E power minus st, e power s, instead of s is a here, bracket minus s sin omega t, common negative, b is omega cos omega t, limit is pi by 2 omega to pi by omega. Let us give upper limit. E power minus s pi by omega divided by, I have not divided by written, divided by minus s square plus omega square. Giving upper limit e power minus s pi by omega minus s sin omega pi by omega minus omega cos omega pi by omega minus lower limit e power minus s pi by 2 omega into minus s sin omega pi by 2 omega minus omega cos omega pi by 2 omega. Upper limit minus lower limit we have applied. E power minus pi s by omega minus s sin pi, omega can sin pi minus omega cos pi, omega cancelled, minus e power minus pi by 2 omega, here omega cancelled, minus s sin pi by 2 minus omega cos pi by 2, omega cancel, cos pi by 2. E power minus pi s by omega sin only t, sin pi is 0, cos pi is minus 1. Here sin pi by 2, 90 is 1. Cos pi by 2, cos 90 is 0. Applying all these in this, minus s 0, minus omega cos is minus 1. Minus e power minus pi s by 2 omega. Minus sin 90 is 1. Cos 90 is 0. Rearranging this, minus plus e power minus pi s by omega by I have not written. For all places I have to write by. Minus s whole square plus omega square. At all places I have not written omega square minus omega square equal to sin pi is 0, cos pi is minus 1, sin pi by 2 1, cos pi by 2 0. In denominator I have not written. At the previous where I have to write, I don't know how, whether I have written or not, I don't know. E power minus s pi s by omega sin pi is 0, omega cos pi is minus 1, minus e power minus pi s by 2 omega sin minus sin 90 is 1, cos 90 is 0. Therefore minus plus plus e power minus s pi by s square plus omega square. Again minus plus plus omega e power minus s pi by omega by s square plus omega square minus plus plus e power minus pi s by 2 omega s by s square plus omega square is the answer. We are getting same answer, getting method 2.